Hi everyone, we're continuing on section 5.3 on solving trig equations. We've been dealing with linear forms thus far. Now we're going to start dealing with powers. For example, quadratic forms and higher. And for these quadratic forms, we may have to factor or maybe use something like the square root method, like before. Remember the square root method. If we have something like x squared equals 7, what could x be? Oh, the square root of 7, right? Not so fast. Don't forget what? Plus or minus. And by trig, a lot of students forget to put that as part of the square root method. And incidentally, for many of these problems, we often grab solutions from all four quadrants. Not always, but we often get solutions in all four quadrants, as will be the case in our next example, which followed up on the last one we did last time. Tangent squared of x minus 3 equals 0. Now, if we had a tangent of x term in here, we might like having the 0 isolated, but since we have tangent squared of x here with no tangent of x term, we may as well isolate the tangent squared of x term and use the square root method. So we're not setting ourselves up for factoring. So we do that by adding 3 to both sides. We get tangent squared of x equals 3. We're isolating this squared expression. And then we apply the square root method. Tangent of x equals what? Not just the square root of 3, plus or minus the square root of 3. Again, on exams, students often forget the plus or minus. It might be wishful thinking. But if anything, this will make things easier for us because of this, we're going to end up with solutions in all four quadrants, which in some ways makes things easier for us. All right. So first of all, we might want to ask the question, well, where is tangent of x equal to the square root of 3, positive root 3? Right? And we dealt with this kind of issue before. We were basically asking for the reference angle that we're going to get. Remember that the square root of 3 is about 1.7. It was that steep slope that we had in our table, right? Our steep slope. So the reference angle is going to be this steep angle, pi over 3. Wow, that's a messy circle there, huh? Let's move this around a bit. There we go. Pi over 3. That's going to be the reference angle for all of our solutions. And in fact, it turns out that the solution set will be all angles, all real radian measures, whose reference angle is pi over 3. We want all the brothers for pi over 3, including, of course, the coterminal twins. So we want all the representatives for all four of these brother points in all four quadrants. Tangent, remember, was positive root 3 in quadrants 1 and 3. Tangent is negative in quadrants 2 and 4. But we don't even have to really draw that distinction. We want values of x, or angles, where tangent is either positive root 3 or negative root 3. So we don't even have to distinguish really between these quadrants. We want these brothers in all four quadrants. It doesn't even matter if the tangent value is positive or negative. Although I hope you know which ones go with which quadrants. We don't have to worry. We want all the brothers for pi over 3. So what would be an efficient way of expressing the solution set? How do we pick up all the brothers for pi over 3 efficiently? Well, pi over 3 is a great representative for this purple point. And if we do plus pi n, we're then going to pick up all the brothers for this point in quadrant 3. If we do plus pi n, where n is integer. Likewise, I'll do this in blue. If we take negative pi over 3, we can add pi n and get all the brothers for this point. And then if we add 2 pi n and so forth, we also get all the brothers for this point as well. Okay, so once again, how do we get all the brothers? So from pi over 3, this is pi over 3 plus 0 pi, and then plus 1 pi, we're here in quadrant 3. If we do plus 2 pi, we're back to this point in quadrant 1. Plus 3 pi over here, plus 4 pi over here, and so forth. If you do minus 1 pi, then you go clockwise over to this quadrant 3 point. Minus 2 pi, clockwise back to a coterminal twin, and so forth. And again, the same deal for negative pi over 3. Negative pi over 3 plus 0 pi, plus 1 pi, plus 2 pi, plus 3 pi, and so forth. Same for minus 1 pi, minus 2 pi, and so forth. We pick up all the brothers in quadrants 4 and 2. So here is the most efficient form for the solution set. The set of all x values in the reals such that x is of the form pi over 3 plus pi n, where n is an integer. Z, I may have put r before, z. All right. Plus or minus pi over 3. And with the plus pi n, we're picking up all the brothers, all the brothers. Now, if you don't like using this type of periodicity, you could go straight to the coterminal twins. This guy plus 2 pi n, or this guy plus 2 pi n, or maybe 4 pi over 3 plus 2 pi n, or maybe this guy, or 5 pi over 3 plus 2 pi n, where n is integer. Or if you don't like negative angles, instead of negative pi over 3, remember, you can take any representative for either red point. You could take 2 pi over 3 plus pi n if you want these two red points over here. So instead of plus or minus pi over 3 plus pi n, you could do pi over 3 plus pi n, and you pick up all the representatives for the purple points. Or x equals 2 pi over 3 plus pi n. That's another way of picking up all the representatives for the red points. And like I said before, if you'd rather think in terms of coterminal twins, you could do this plus 2 pi n, or this plus 2 pi n, or a rep here plus 2 pi n, or a rep here plus 2 pi n, where n is integer. That would take a lot of writing, but some students feel more comfortable with that. Books do try to aim for the most efficient expression. They'll probably aim for this. On some sort of exam, I would accept any of those forms, though. Any form that is correct and that is reasonable. Okay. Oh, and by the way, we could also go to Desmos. Let's do that in the next video.